Soap is used to wash many things like dishes or clothing, and in every case, it's acting the same way. It works as something called the surfactant, which emulsifies oils and allows them to be carried by water. Historically, soap was made by using a combination of rainwater, animal fats or vegetable oils, and ashes. Over thousands of years, the process was slowly refined, and it was eventually discovered that the major ingredient in the ashes was base. For a very long time, all soap was solid soap, and it wasn't until 1865 when a man named William Shepard patented a liquid version. From then on, more and more liquid-type soaps were developed, and now we have a huge variety of different options. The invention of a proper liquid form of soap was actually a pretty big deal because it made it a lot easier to clean things like floors and clothing. Soap is derived from triglycerides, which are the fat storage molecules used by almost all plants and animals. Animal fats and vegetable oils are almost just pure triglycerides. There are two major parts of the triglyceride molecule, the glycerol backbone and the fatty acid tails. An ester bond connects the tails to the backbone, and it's a relatively sensitive bond. When triglycerides are treated with a strong base like sodium hydroxide, they undergo a saponification reaction. This leads to the breaking of the ester bond and the formation of glycerol and fatty acid salts. These salted fatty acids are pretty much what soap is. One end has a strong charge separation which makes it polar, while the long carbon chain tail is nonpolar. The polar end is hydrophilic, literally meaning water-loving, and the chain is lipophilic, meaning fat-loving. In general, nonpolar molecules dissolve in nonpolar liquids like oils, and polar molecules dissolve in polar liquids like water. Because this molecule has both of these properties, it acts as a sort of bridge between the oil and the water. When soap is shaken with water, the molecules arrange themselves into spherical structures called micelles. The hydrophilic and polar heads are on the outside in contact with the water, and the nonpolar tails are shielded on the inside. The micelles are not technically dissolved in the water, and they exist as a colloid, which is a very finely dispersed suspension. If oil is present, micelles can pick up and hold a small droplet in their nonpolar interior. The tails on the inside dissolve into the oil, and the entire droplet is protected from water. The polar heads give the surface a negative charge, which helps repel other micelles. This prevents the oil from coalescing, and it keeps it separated as very small, stabilized droplets. When it comes to making soap, it can be surprisingly complicated. It always involves the base hydrolysis of triglycerides, but the ingredients and the process differs quite a bit. Depending on the base that is used and the source of the triglycerides, the final soap can have very different properties. With the fatty acids, the most important characteristic is the chain length. As chain length increases, it becomes less polar and therefore less soluble in water. Soaps from long-chained fatty acids also tend to be harder and they don't lather as easily. The base that is used will influence the fatty acid salt that is made in the end. For example, with sodium hydroxide, we get sodium salt fatty acids, which tend to be harder and less soluble. Potassium hydroxide forms much softer and more water-soluble salts, so it's the base that's used to make liquid soaps. It's not as common, but lithium hydroxide can also be used to make lithium soap. However, this soap isn't meant to clean things. It's usually dispersed in an oil to form a thick lubricating grease. It's non-corrosive, sticks well to metal, and it's used to lubricate a lot of household products. Soap can be made by two main processes, a cold one and a hot one. The hot one is carried out at around 90 C, and the cold one is close to room temperature. The major benefits of the cold process is that it's easily molded to many different shapes, and it's compatible with a wide array of additives. The major downside is that it usually takes 4 to 6 weeks to cure before it can be used. The benefit of the hot process is that it's fast and it only takes about a day to cure. However, it's very thick and it can only be molded to very basic shapes. Also, because it needs to be heated, a lot of additives aren't compatible. For this video, I've decided to cover both processes, and I'll be making both solid and liquid soap. It's a lot to cover though, so I've split it into two videos. For this one, I'll be making solid soap by the cold process, and in part 2, I'll make liquid soap by the hot process. Okay, so to make the solid soap, I'm going to need 3 major things: olive oil, coconut oil, and sodium hydroxide. It's also possible to use other oils like sunflower oil or almond oil, and the properties of whatever oil you choose to use will change the characteristics of the final soap. At the store, there are a few types of olive oils that you can buy, but when it comes to making soap, it really doesn't matter too much. On the right, I have all of the additives that I plan to put into the soap. With the cold process, we can use a lot of different additives, and I'm going to be putting in things like lavender, cinnamon oil, and maple coffee. One thing I want you guys to remember is that making soap is kind of like cooking, and there's a lot of different things you can do. The recipe that I'm following is just one of thousands, and if you decide to try it yourself, don't feel like you need to do exactly what I do. I strongly urge you to do a little bit of searching online and find the recipe that suits you the best. To start things off, I need to make a sodium hydroxide solution, so I measure out 200 milliliters of distilled water. I then weighed out about 80 grams of sodium hydroxide. Sodium hydroxide is a strong base, so you should be careful when working with it. However, unlike what they showed in Fight Club, touching it isn't going to melt your skin. If you get it on your skin or hand, just quickly remove it and, for good measure, wash it with a bunch of water. Anyway, now it's time to dissolve the sodium hydroxide, and this is where the real danger comes in. Unlike the solid form, a solution of sodium hydroxide is much more corrosive. Also, dissolving sodium hydroxide generates a lot of heat, and the solution will get pretty hot. You might notice here that I'm still not wearing any gloves, and this is because getting it on your skin still isn't that bad. However, if you were to accidentally splash some into your eyes, it could quickly cause major damage and potentially blind you. So for this step, some form of eye protection like goggles is absolutely mandatory. You can also wear something like a lab coat to protect your clothes if you're worried about damaging them. Just to show you it's not the end of the world to get it on your skin, I purposely dipped my finger in. After doing this, I just washed my hand with some water, and there was absolutely no irritation or anything. Anyway, all of the sodium hydroxide eventually dissolves, but the solution is still quite hot. So I temporarily place it on the side to cool, and in the meantime, I prepare the oils. So for the olive oil, I need 500 grams, and I weigh it out just using a kitchen scale. When I'm done, it's placed on the side, and I move on to the coconut oil. The oil is solid, so I have to scoop it out using a spoon. When I'm done weighing out 100 grams, I put it in the microwave. The melting point of coconut oil is only a little bit above room temperature, so it doesn't take much heat to completely melt it. The now liquid coconut oil is then mixed with the olive oil and stirred thoroughly. To the mixture of oils, I add the sodium hydroxide solution from before. The moment it's added, we can already see some cloudiness, which is the beginning of the reaction. Using a spoon, I give it a quick mix, and then I continue things with a hand blender. Before starting things, I covered the top with a little bit of plastic wrap just to try to prevent some splashing. Anyway, if you're going to be making soap by the cold process, I strongly suggest investing in a hand blender. I think this one was only like $10 or something. It's definitely possible to do it manually, but it takes a lot longer. Okay, so what we have going on here is known as a saponification reaction. The ester bonds in the triglycerides of the olive and coconut oil are being hydrolyzed, forming salted fatty acids and glycerol. In terms of the mechanism, we start with an attack by the hydroxide ion, which opens up the carbonyl. The electrons on the oxygen move to reform the double bond, and the carbon-oxygen bond between the fatty acid and the glycerol is broken. The negative charge on the oxygen of glycerol then picks up the acidic hydrogen of the fatty acid. This reaction is repeated 2 more times to completely detach the glycerol backbone. When making hard soaps, it's very important to use slightly less sodium hydroxide than is needed to completely saponify all of the oil. Sodium hydroxide is consumed in the reaction, and we want there to be little or none left in the end. Otherwise, it can sometimes be irritating to the skin. Also, leaving a little bit of extra oil in the soap will make it softer on the hands and less dehydrating. This idea of using more oil than is needed is generally known as superfatting. Because this is all done cold, the reaction is quite slow and takes around 2 weeks to be complete. It's then left for another 4 weeks to let extra water evaporate off, which helps harden the soap. With very little blending, it really doesn't take long to get to a stage called trace. At the trace point, we have a stable emulsion and the oil will no longer separate. However, the soap might still be quite watery at this point, and if we continue to mix things around, it's going to thicken up. There's no real perfect thickness to go to, and it's really just up to the person making the soap. There are some people who like to stop when it's very thin and watery, and others who like to keep going until it's quite thick. Based on what I read, the point at which you stop doesn't really affect cure time or anything like that, and it mostly just affects design possibilities. Light trace is very liquidy, and it seems to be the best for making swirled designs. It's also an ideal point to put in liquid additives because they're going to mix in really easily. Medium trace is good to add in solid things like poppy seeds or coffee grounds because it's still easy to mix, but they're going to stay suspended in it. Thick trace is quite viscous and it holds its shape when it's manipulated, so it's really good for making textured designs. It's also good if you want to make soap with multiple layers. Anyway, I'm not doing anything fancy and I just kept going until about a medium-ish trace. I chose to go to this point because I need to mix in both liquid and solid additives, and I can do it all in one batch. I wanted to make 7 different types of soap, so I transferred almost all of it to separate beakers. I tried to put an equal amount in each one, but I clearly kind of failed. To the first beaker, I added essential cinnamon oil, which is pretty much just pure cinnamaldehyde. Then using my stir rod, I mixed it up as best as I could. One thing to point out is that I'm not an expert at all with this, and in each case, I think I added way too much stuff. When I was done, I quickly marked the beaker CIN for cinnamaldehyde, and then moved on to the next one. For this one, I added essential bitter almond oil, which is more or less just benzaldehyde. Benzaldehyde has a really nice almond odor, which smells like cherry candies. A major reason why additives are put in after we reach trace is because at this point, most of the sodium hydroxide has been consumed. Certain things, especially cinnamaldehyde and benzaldehyde, are quite sensitive to strong base. If they were added immediately at the beginning, a lot of it would have reacted with the sodium hydroxide and been destroyed. In the third one, I added freshly ground lavender. For the fourth one, I used a bunch of dark cocoa, and the final result looked like chocolate pudding. In the next one, I decided to make an exfoliator, so I poured in some poppy seeds. I felt that poppy seeds alone might have been a little bit too simple, so I put in some drops of food coloring. I purposely didn't mix it in completely, so I could get a little bit of a swirly color effect. For the sixth, I melted a whole bunch of menthol crystals and dumped them all in. Menthol has a very strong minty odor, and it's kind of the opposite of spiciness. Instead of inducing heat, it induces a sensation of cold. For this batch, I added way too much, and it's probably going to actually hurt to use this soap. I figured that since it's minty, it would make sense to make the soap green. However, after mixing it for a while, it somehow became orange instead. Anyway, for the last one, I used maple coffee grounds. I mixed it thoroughly, and then I went back to the first one and shot in a bunch of red food coloring to make the cinnamon one pink. Okay, so now it's time to mold the soap, and you can either buy one or make it yourself. I decided to do it both ways, and I would just make one custom mold. To do this, it's pretty easy. I just mix an equal amount of each part and blend it until it's one uniform color. I then squished it around the bottom of a beaker, and I included a 3D printed model of the caffeine molecule. When the mold was ready, I removed the beaker and I pulled out the plastic molecule. Then using some scissors, I cleaned up the edges, and it's pretty much good to go. By the time I started transferring things to the molds, it had already become a lot thicker. However, one thing to notice is that each batch isn't the same, and this is because different additives can affect the thickness. So for example, the first one was cinnamaldehyde, and although it was thick, it still looked a little bit liquidy. Now with the benzaldehyde, you can see it's much thicker than the last one, and it's almost like a paste. Most of the other ones were relatively liquidy, except for the menthol, which was also a paste. Anyway, it was a little bit messy, but I eventually transferred everything to the mold. Using my finger, I cleaned it up, and then I temporarily placed it on the side. So now to the mold I made, I added the coffee one. Using the spoon, I pushed things down to make sure that the molecule was completely filled. So at this point, I was pretty much done, but I apparently had still a little bit more soap left in the original container, so I filled another mold. For the third mold, I did the same as the first bar of soap. I just added cinnamaldehyde and a bunch of red food coloring. I left it out overnight, and by the morning, it had hardened quite a bit. So now that it has cured a little, it's time to demold everything. At this point, all of the soaps are solid, but they're still relatively soft. While it's still soft, it's a good idea to shape things because it's very easy to cut through it. If you wait until it's fully cured, it's going to be a pretty big pain. When I demolded the smaller cinnamon oil soaps, you can see that they weren't quite done. As we just saw before, the additives can affect the thickness, so it's not too surprising to see that it also might affect the cure time. And if you don't take this into account, you'll end up demolding soap here like I did, and having some of them fall apart. Anyway, I went ahead and demolded them all, and you can see that for the most part, they were pretty good. There was just a couple terrible ones. These ones were the last to be demolded, and they were pretty easy. Just visually though, you can see that the cinnamaldehyde and the menthol ones are quite a bit softer. Now I need to wait about 4 to 6 weeks for all of the soap to cure. All of the soap should be turned over at least once a week to make sure that it dries out properly. This is 6 weeks later, and at this point, the soap should be done. All of the pieces pretty much look the same, except they're definitely a lot harder than when I started. So now to test out the soap and see how well it works. I decided to go with the menthol one because I wanted to see how much of a cooling effect it would have on my hands. Based on how much I put in, I was expecting it to burn quite a bit, but I didn't feel anything at all, so apparently I actually made a decent bar of soap. Anyway, now that I've successfully made solid soap, I'm going to move on to part 2 where I make the liquid version. I strongly urge you guys to check it out because, well, at least I think it's interesting. Also, I make it using the hot process, so you can see how that compares to the cold one. You can find it by either clicking the link on the screen or in the description. I originally planned to keep all of the soap that I made, but at the last second, I've decided to give most of it away. I'm going to be doing the same promotional type thing that I did in a previous video, where all you need to do to enter is either follow me on Twitter, visit my Instagram, or subscribe to me on this YouTube channel or my other channel, NileRed. The link to the contest will be in the description, and this time I'm going to go with 5 winners, so the chance is going to be much higher. Each winner will get a random bar of soap, not including the caffeine one because I want to keep that, or the menthol one because I kind of used it. I'll ship everything completely free of charge, and I'll also ship it anywhere in the world. And just one last thing. The winner to my previous contest, Ju Young, never responded to my email and never got in contact with me. So Ju Young, if you're listening to this, I'm going to give you another week to contact me either through Twitter or by email, otherwise I'm going to draw another winner. A big thanks goes out to all of my supporters on Patreon. Anyone who supports me will see my videos 24 hours before I post it to YouTube, and they'll also be able to directly contact me. Anyone who supports me with $5 or more will also get their name at the end of the video like you see here. In the very last shot of my video here, I want to start including music. I don't really want the typical royalty-free stuff, and I'd rather support some artists with some free advertising. So if you're interested, just send me an email or contact me on Twitter, and if I like what I hear, I'll include it.